Yes, now we'll discuss about another standard result, which is limit x tends to a, where x power n minus a power n divided by x minus a. So in this case, what should we do? Sorry, this is already we discussed. Right now we'll discuss something similar to it. Okay. So where, like, we'll take x power m minus a power m divided by x power n minus a power n. In this case, what to do? So we have a standard result, which is m divided by n into a power minus m minus n. So we have a standard result, but how did we get this standard result? So that is what we are going to discuss now. So do you remember our previous standard result, which is if limit extends to a and x power n minus a to the power of n divided by x minus a. So try to convert this into this form. Okay, that means in the denominator it has to be x minus a, but here you don't find an x minus a, instead you found x power n minus a power n. So we'll convert it. How? I will just like multiply and divide with x minus a. So see, limit extends to a, x to the power of m minus a to the power of m divided by x to the power of n minus a to the power of n into x minus a by x minus a. So if this gets cancelled, that limit doesn't change, right? So here I can rewrite this into limit x tends to a, x power m minus a power m divided by x minus a into x minus a by x power n minus a power n, right? So this is like in reciprocal form, right? So now I divide limit with one of its properties, like one of its limit properties, x minus x, limit extends to a f of x into g of x can also be written as limit extends to a of f of x into limit extends to a of g of x. So x power m minus a power m divided by x minus a into limit extends to a. It's like x into a plus b equal to x ax in plus bx, like that, by x power n minus a power n. So now apply this. This is equals to n into a power n minus 1. So in first case it would become m into a to the power of m minus 1. In the next case it would become 1 by n into a power n minus 1. So which is m by n into a to the power of m minus 1 by a to the power of n minus 1. Here the in like in exponential we learned already. If like it is 2 power 3 by 2 power 4, you can write it as 2 power 3 minus 4, right? So similarly here I will write m by n into a to the power of m minus 1 minus n plus 1. Minus of minus will become plus. So 1 and 1 gets cancelled and it will become m by n into a to the power of m minus n. So that you got your result, right? If you have any doubts, mail me. So after this we'll discuss another standard result, which is sin x by x. So here if limit x tends to 0, sin x by x is equals to 1. So how we'll prove this? So you know this like sin x can be written like it has a series, it's called sine series. So like you should know all this series. So that is sine video record is on a class. So that is sin x is equals to x minus x cube by 3 factorial plus x5 by 5 factorial minus so on up to, it keeps on going, it varies. So this is sine series. So this sine series we'll use to prove the standard result. So we'll see how. Just we substitute in the place of sine x this series. So limit x tends to 0, 1 by x into x minus x cube by 3 factorial plus x power 5 by 5 factorial plus so on. Okay, so we take x common. So that means limit x tends to 0, 1 by x into x, 1 minus x square by 3 factorial plus x power 4 by 5 factorial plus so on. So here if you observe, x gets cancelled and apply limit x tends to 0. That means we can put x equal to 0. So if you put x equal to 0, 0 by something is 0, 0, 0. So what is remaining? 1 is remaining. So limit x tends to 0, sin x by x is equals to 1. That's it. That's how it is proved. Similarly, tan x. Tan x also has got its own series, but we don't use it. We use a different method to solve this. So that is very simple. I'll show you. So limit x tends to 0, tan x by x equals to 1. So here right, tan x is as sin x by x. Like we already know sin x by x equals to 1 when limit x tends to 0, right? So try to convert tan x into sin x. So you know tan x is equal to sin x by cos x. So limit x tends to 0, sin x by cos x into 1 by x, right? So now sin x by x. So just rewrite it. Limit x tends to 0, sin x by x into 1 by cos x. So this is 1. So now limit x tends to 0, 1 by cos x. So 1 by cos x. So substitute 0 like take limit inside. So that implies 1 by cos 0, which is, cos 0 is 1. So 1 by 1 is equal to 1. You got your result. So these and there are some other standard results. For the other standard results, you refer my notes. If you have any doubts with other standard results, let me know. We'll solve. And in my notes, I have also given the sine series, cos series, sine head series, everything. So in future, if you find anywhere like you have to use your series, then use them and try to get it solved. So and in the next video, we'll discuss about L'Hospital rule. So you know in this I just like when you have trigonometrics in like I discuss these two identities because in order to like make you understand how to like handle trigonometrics in limits. So you have some standard results, use them and get them solved. I'll discuss all these standard results of trigonometrics in our trigonometric lecture. For now, you just remember them. Okay.